Hello, and welcome to a video on reaction stoichiometry, looking at mole-mole ratios. Given moles of one substance, calculate moles of another substance. Alright, and this video is focusing on method B. That's just kind of a name that we're using to say it's different than method A. Alright, so the key to this is always getting the correct balanced chemical equation and then utilizing it to convert moles. Alright, in the previous video we learned that burn means combustion, and combustion reaction means fuel plus O2 gives CO2 and water. We learned that oxygen is O2, and we learned that propane is C3H8. So we can write our balanced chemical equation. Propane is the fuel, C3H8, plus O2, I'm leaving space in there to write the numbers in just a minute, gives the product CO2 and H2O, because this is a combustion reaction, so we have a separate video on reaction types. Alright, balancing this, let's see, I do the C's and then the H's and then the O's. Nice. This one turns out very nicely for balancing. I can, after I write my balanced chemical equation, I check it and double check it because it is key for getting the problem right. Then I write what I'm looking for and what I'm given. Alright, and so now as I mentioned, we're going to use method B, just a different method than we did in our last video for solving this kind of problem. Alright, and method B is to look at ratios, okay? So we're going to do ratios and we're going to do cross multiplication. So for these ratios, I'm going to put whatever X is on top, so O2 will go on top, and then on the bottom I'm going to do C3H8, okay? So I get, so the first ratio I write will be from the balanced chemical equation, and that is 5 moles of O2 on the top, and not 2.1, no. Don't do that. It's 1 mole of C3H8. Now, how in the world did I get that? It is from the balanced chemical equation. This 5, let's see if I can circle it, came from right there. And this 1 came, excuse me, from right here, that implied 1 out in front. Okay? So that is the balanced chemical equation. Now let's look at how to interpret this. Literally, the balanced chemical equation is telling us that for every 1 mole of propane, we need 5 moles of O2. Now stick with me here just a sec. So if we have 2 moles of propane, how many moles of O2 should we need? Yeah, 10. You know, I just doubled the first number, I got to double the second one. So we're using that logic to solve this, okay? So for every 5, I need 1. Okay, so how many moles of O2 do I need? If I don't have 1 and I don't have 2, I have 2.10 moles of C3H8. Now I can cross multiply and solve for X. So I get X is 10.5 moles of O2 are needed. I'm going to go ahead and write it in complete sentences because it's just a really good study technique that helped me a lot. Are needed to completely burn 2.10 moles of propane. Alright, so this is another way of doing reaction stoichiometry using the mole-mole ratio. Just looks a little bit different. Math is the same as for method A, just the setup is a little different. Of course, use whichever method makes most sense to you. Our strongest students will usually learn both methods and then use whichever one. They'll go between one or the other method at their leisure, whatever makes sense to them at the time. Thank you, and see you in the next video.